Hello, I'm sorry there's been such a long delay between the last machining video and this one. I've just had other things to do. I never really started this channel with the intention of producing one video every week, and actually it's an enormous amount of effort to produce one video every week. So I'm afraid you just have to take them as they come and realise that there are other things in life than making YouTube videos. I'm reverting now to testing the M300 to try and get a better idea about how accurately one can turn diameters on this thing, given that the ways are badly worn. I haven't touched this tailstock at all. Haven't disassembled it or cleaned it or anything, but I thought I'd just test its left-right alignment, and up-down for that matter. This is a nominal 42 millimeters, and I'm going to turn down this piece of scrap to 42 millimeters and then see whether the two things line up. And we've just had a power cut. How brilliant. Right, well, this has cooled down now. It's the next day. .56, and I'm shooting for 41.998, essentially 42. So we've got 0.56 to come off. That is 0.25, and I hope that this is a finishing cut. This is 1200 RPM. Yes, 42.024, which is just a thou over, I think. So I'll use some emery paper on it. Well, that's 41.998, which is exactly the same as this. So that will do. So I've clocked this in on the forejaw, and that is as close as I can get it. And that was more by luck than judgment. I think it's within a third of a thou. So my point is, if I put the headstock in here up to there, is it lined up? I would say it is slightly too far that way by the Mark I eyeball and fingernail. Right, well, I've got the indicator on the side of the thing. That's the run out on it. And now I move it to the right onto the tailstock. it goes down by 25, just over 25. Which means that the tailstock is 25 that way. If we continue to go to the right, it continues to go down. And I don't know whether that's because the tailstock is like that, or whether it's the wear on the ways moving this relative to that. And if we come back onto here, and then move along this machine surface, it's going up. I can't go any further than that much, but it's going up so that there's a taper on here. This is narrower than the bit back there. Subject to the same qualification about whether it's the ways or the worn ways rather than the thing. So I put it on the other side. If we move it, it goes to what? 26. So it needs to go 27 in that direction, this tailstock. Right, now I'm measuring it in the vertical dimension. If we get onto the top of this, like that. It gets 10 higher, and this does not change much along there, so this, at least it's level in that respect. I have not done anything to this tailstock since I bought the lathe. It's never been the same colour as the rest of the lathe, so I'm wondering whether it's actually came with the lathe originally or whether it's been swapped around and mixed and matched. Obviously I can adjust it here this way. I don't know whether the offset that exists of 27 microns that way, whether that was deliberately done by the previous owner in order to kind of correct the taper that results from the worn ways, or whether it's just totally random. I'm inclined to put it back in alignment and then see what taper it cuts. So to bring it into alignment, I think I undo this grub screw here, which I've already done, and I want to move it 25 that way. So if I loosen this, and tighten the one on the other side, if I tighten the one that's going to move it that way, that's the wrong way. I need to loosen that one. If I tighten this, it's going to pull it that way, isn't it? Right. And I want 25. That's 25. Now if I tighten this, and tighten this for the sake of safety, or belt and braces. There we are. Don't see how that can be any better. Well, that's better, but it's still slightly, it's going down 5 rather than 20 now. Right, so let me just adjust it here. Right, okay, that's about the nearest, damn it. Let's see if I can do it up like that. Well, that's near as damn it as I can get it. And I'm not going to adjust the height, because there isn't any way of adjusting the height other than scraping it. Right, so this is a 67mm diameter mild steel bar, supported on the tailstock on a knife centre. And I'm going to make a 0.5mm depth of cut, which is a light cut. 1, 2, 3, 4, 5. And we'll see what kind of taper it produces, hopefully. Slightly warm. Very horrid stringy chip that produces. So, yeah. I do not have a micrometer that will handle this, so I've got to do it with this. Let me see if I can get this a sensible way around. Can't actually see what I'm doing. I would say that that is 66.41, and this 66.56. So that is 0.15mm taper over this distance, which is, say, 125mm. So it's basically 6 thou over 5 inches, isn't it? Which is far too much. That's what I'd say. Far too much. And we could reduce it slightly by pushing the tailstock that way, as it was before I corrected it. Of course, it's a fight between the chuck and the tailstock, how it actually lines this up. The tighter this is, the more I mean, this is a substantial chunk of metal, isn't it? So I can't put it at an arbitrary orientation in here. Anyway, the point is, it cuts too much for taper to be a decent lathe. That's my point. Anyway, it produces a perfectly good finish. Well, I've just been experimenting with cutting this bar, which is 10 inches long, with the end in the inner live centre, and then adjusting the tailstock left to right in order to get the difference between the diameter here and here to a minimum. And after a bit of fiddling, I've got it to that, where this is 23.933 and this is 23.928, so it's 5 microns difference, which is just under 2/10 of a thou, which is good, I think. However, if we measure in the middle, it's about 3 thou fatter. That presumably is due to deflection of the bar under the cutting. Maybe I should have taken several passes at the exact same setting, a spring pass, to get rid of that. So this graph shows the results of a test I was doing a bit earlier when the bar was about 5 millimeters thicker, and the blue line shows the result before I adjusted the tailstock, and the orange line shows the result after adjusting it. But now what interests me is that I think that this will only work for this particular diameter of workpiece and this particular position of the tailstock. So I'm going to push this back into the chuck further and try a cut again and see whether we get a similar result. Right, so that is only 5 inches, half the stick out we had before. Otherwise exactly the same setup. So there's 23.468 at the right hand end and 0.334 at the chuck end. So that is 134 microns of taper over this 5-inch length, and the taper is in the opposite direction to what we observed with the 10-inch length rod. So that just goes to show that correcting the tailstock to give you a good even cut at a particular position and length doesn't work for anything else. Well, this is 40 millimeters in diameter, and I intended it to be exactly 10 inches stick out as we had with the first bar, but because I forgot to take account of the fact that some of it has to be in the chuck, it's actually 8.5 inches stick out. Right, this is 0.5 millimeter depth of cut, 0.1 millimeters per rev, 1200 RPM. Exactly the same settings I had before, except that this is 40 millimeters rather than 23 millimeters. We'll see what happens. So that is 39.113 at the tailstock end and 39.090 at the chuck, which is okay, but it's 0.172 in the middle, which is not okay. There's 23 microns between one end and the other, which is just under a thou, whereas at the middle it's 82 microns, which is 3.2 thou. refuse to believe that that is caused by bending. It must be something to do with waves. Well, I did those tests back in June, but it's been such a long time since I posted anything that I've only got to them now. What they show, I think, is it's extremely difficult to turn a long piece accurately on this lathe, and even short pieces are likely to have a taper on. I would say one thing, some people will be tempted to say, have you levelled the lathe properly? Well, I did level it properly to start off with, but I discovered that it doesn't actually make much difference. The thing is quite rigid, and I can in fact jack this lathe up on two diagonally opposite feet, leaving the other 2 feet in the air, thus applying maximum twist to it, and it doesn't actually make much difference to the way the lathe performs. So I don't think levelling is really the problem. Since then I've been using the lathe for quite a lot of projects, but they aren't really anything much that I could film. But it's been quite fun using it. And more recently I've done some tests turning between centres, which I will show in the next video because that's quite interesting, and I've learnt something which I didn't really know beforehand. So thanks very much for watching. This is 50 and we want it down to 42, so there's plenty to come off. This is 2mm depth of cut at 800 RPM. Well, that was no good. Right, well, this is 260 RPM. Hurry, didn't it? $180. Yeah, that's broken it. Not only broken the insert, but also the entire thing, which wasn't a very good one anyway. But right, we'll have to use a hacksaw for the rest of that.